Hi, I hope everybody is doing well, keeping their social distance, washing their hands. You survived 2 days of your NTI. This is our third day. This works best if you have watched Tyler Tarver's instructional video first. But if you just want to do the notes with me and then try some practice problems, that's fine too. We're looking at proving parallelograms, and to do that, we're going to use the converse of what we've been doing. Now, on this it says in a coordinate plane. We're not going to do it in a coordinate plane. However, I will tell you how to do it in a coordinate plane for some of you eager beavers. If you want to go out there and research some of that, you can do that. I will tell you how to do that in a coordinate plane, but we're not going to actually practice that. Okay, we have 3 different ways to prove that something is a parallelogram. First way we're going to look at is you can prove it's a parallelogram if both pairs of opposite sides are congruent. Notice it has to be both pairs of opposite sides. So using our picture here, we would have to show that segment AB is congruent to segment DC and segment AD is congruent to segment BC. Then we know that ABCD is a parallelogram. If you're working in a coordinate plane, you would use the distance formula. Okay, another way to do that is to prove that both pairs of opposite sides are parallel. Again, it's got to be both pairs of opposite sides. So on that, we would be showing that AB is parallel to DC and AD is parallel to BC. To show that things are parallel in the coordinate plane, we would be using the slope formula. And then our third way is to have one pair of opposite sides that are congruent and parallel. So it's one pair of sides that's both congruent and parallel. It's got to be the same pair of sides. So an example of that might be that AB is congruent to DC and AB is parallel to DC. So it's got to be the same pair of sides, both congruent and parallel. So if you're going to do that, you would use the distance formula. And the slope formula. So you need both of those. Again, this is what I would consider bonus work. We're not actually going to be working in the coordinate plane. Okay, so what are we going to be doing? Let's come down here and look at some of these examples. Please bear with me as I stumble through using my camera. It's easier if I just move the paper. Work smarter, not harder, right? Isn't that what I always tell you guys? Bear with me, guys. I'll figure it out someday. Okay, so down here on example 1, if each quadrilateral below is, what is a parallel? Oh, this is the same old stuff we were doing. You don't need help with that, right? These are parallelograms, find the missing measures. So you should be good on that, right? Okay, let's go to the second page. Okay, this is just more practice of the same old, same old. I tell you what. Let's jump down. Let's look at 8 and 9. Because some people did have some problems with this on the NTI 5. Thursday, we're going to have a quiz. I'm going to put a quiz out there on Thursday. So Thursday, a quiz over parallelograms. Make sure you know there's 5 properties for a parallelogram. So just kind of throw out the window just what we did. Good things to know, because when we get to rectangles, you're going to need to know how do you know that it is a parallelogram. So, but for the quiz, this is the only kinds of things you're going to need to be able to do. Come down here, let's look at number 8 together. And for those of you who have not done, especially your NTI 5, this will be helpful. So for number 8, measure of angle BCD is 51 degrees. BCD, that's this whole angle. What I do is I write it on the outside if it's the whole angle, and we've got the diagonal in there. Okay, so that's 51 degrees. We're supposed to be solving for x. Well, my x is over here on this angle. Okay, so I ask myself, if I'm dealing with this angle, I need to know this angle measure. I've got this 55 down here, this angle and this angle. If we were in class, I'd ask you, what kind of angles are those? Somebody would say out there, alternate interior angles, Miss Rankin. Yeah, good job, guys. Alternate interior angles. I got alternate interior angles. And then I'd say, what do we know about alternate interior angles? And somebody else, because you guys are so smart, would say, they're congruent. Yes. So this angle is 55 degrees. Because you guys are so smart. Okay? That angle's 55 degrees. This whole angle's 51 degrees. Now, what do we know about these angles? What kind of angles are these? They are consecutive. Okay, consecutive angles. 5 properties of a parallelogram. Consecutive angles are supplementary. They add to equal 180. Okay, make sure you know your properties. Make sure you know what supplementary means. Had a couple of people add them to equal 90. Okay, be careful. Add to equal 180. So that means all of this has to add to equal 180. Couple different things you could do. You could combine everything, set it equal to 180, or you could do 180 minus 51 minus 55. Well, this is 106, right? So let's just, what's 180 minus 106? And golly, I don't have my Smarties here to do my arithmetic for me. So what is this? 74, right? So what's left over? When I do 180 minus this, I have 74. That means this angle has to be 74 degrees. So what do? I set this equal to 74. So I've got 14x plus 4 equals 74. Okay? And I'm going to go ahead and stop there so the video doesn't get too long, because I know you guys know how to solve that. Hope you guys are all good. If there's anything you need, and by anything, I mean food, something to keep you warm, I don't care what it is, guys, let us know so we can get a hold of whoever can get you whatever it is you need. Remember, we love you. Take care. Peace out, guys. Miss y'all.